All right, so here we have a particle that's moving. It's moving, okay, with respect to this function. Okay. So we want to find the velocity. We want to find when it's at rest. We want to find the acceleration, and then we want to find if it's speeding up or slowing down. Okay, let's recall this relationship. Position, velocity, acceleration. If I want to go this way, if I have position and I want velocity, I take a derivative. Alternatively, if I want to go back up, I do the antiderivative, but we don't need to know that for this problem. All right, so we have position. So velocity is just going to be the derivative of our position function. Our position function is this guy. So she's going to be 6t squared minus 12t plus 6. Awesome. That's all we needed. Now it asks me, when is the particle at rest? I.e., when is the velocity equal to 0? So what instances in time? So my solution should be a time. Okay? So let's take our derivative that we have, and let's set it equal to 0 so we can solve for t. What do all of these have in common? Yes, 6. So let's do that. All right, moment of truth. Do we know how to factor? I hope so. So we get t equals 1. So the only time that the particle is at rest is after 1 second. Awesome. All right. Acceleration. Well, let's go back up to our chart. We have velocity, and we want to get to acceleration. So we take a derivative of velocity. So acceleration at time t will be the derivative of the velocity, which will give us 12t minus 12. Now it's asking me to figure out if the particle is speeding up or slowing down at t equals 2 seconds. We need to check two things here, all right? We need to check the velocity at 2 and the acceleration at 2, okay? The reason being is we have 4 scenarios to consider. Let's say my velocity is positive and my acceleration is also positive. That means my particle is speeding up because acceleration and velocity are moving in the same direction. What if my velocity is this way and so is my acceleration? Well, I'm still going to be speeding up, just in a different direction. So just because one of our things is positive does not mean something's speeding up or slowing down. Because if my velocity was positive and my acceleration was negative, these guys are working against each other. So I'd be slowing down. Right? Same thing if our velocity was negative, but our acceleration was positive, it would also be slowing down. That's why we need to check both, not just one of them, okay? So let's see. Our velocity at 2 would be 6, 2 squared minus 12 times 2 plus 6. And our acceleration is going to be 12 times 2 minus 12. So it looks like we're at 24 minus 24 plus 6. So this is greater than 0. And then over here we have 24 minus 12, which is also greater than 0. So because they're both greater than 0, we can conclude that we are speeding up at t equals 2 seconds. So if you just showed me acceleration or you just showed me velocity, that's not enough information. You have to show me